Hello guys, welcome back to our channel. My name is Henry, and today's session we're going to look at analysis of an RCC frame, concrete frame in Etabs. I would like to guide you to like, share, subscribe, and turn on the notification bell to be able to motivate me for other tutorials. So this is how far we've gone with our project. So before we analyze, we must do some checks and ascertain that our model is okay. So at the start, we have to first define a diaphragm to be able to make the structure act as a one single unit for all structural elements in that view. And our diaphragms will be defined according to the number of floors we have. So in this case, we have 3 floors. So that means we shall have 3 diaphragm definitions with rigidity as rigid. So you are down in diaphragm D2, and diaphragm D3. Okay. So now we have to assign our diaphragm to the ground floors, second floor, and the third floor. So we shall come to the first floor. This one is the active view. So this is our foundation, so this is the first floor. So we select the entire floor. Then we shall go to assign tab, joint, then diaphragms. So we shall assign diaphragm 1 to the first floor. Okay. So we've assigned our diaphragm, so we shall go back to the second floor. Repeat the similar joint, diaphragms, D2, apply. We didn't select, so we shall select the entire floor. This floor to assign joint, diaphragms, D2, apply. Okay. So we shall again assign to the third floor, select the floor. Assign joint, diaphragm, D3, apply. Okay. So now that we're done with assigning diaphragm, we shall go to meshing the members before we carry out our analysis. So we shall first mesh the slab, then after we shall mesh the structure. So this software is based on the finite element method or finite element analysis. So we shall go to the select tab. We select the slabs we are to mesh. So select properties, and then slab sections. So we use this floor slab in the model as our type, so we shall select all. Then after selecting, we shall go to the assign, then look out for the shell, then go to the flow auto mesh options. So in the flow meshing options, we have to enable mesh objects in 2x2 Then we shall need to enable add restraints on edge if corners have restraints. Then we apply. Then okay. Then after we again select the shell members, select the previous selection. Then we need to assign auto edge constraints. Go into the Assign tab. Shell, then auto edge restraints. So in this, we need to enable create edge restraints around walls and floors, but in our model we only have floors. Then enable apply full structure. Okay. Then now we do the meshing of the frames. So we shall come to select properties, and then frame sections. So here we shall select the beams and columns used in our model. There are these two. Select. Then we shall go to the Assign tab, Assign frame. Then we shall look out for the frame auto mesh options. So in this case, we can maintain the default values, apply. Okay. Then you can select the previous beams and columns to be able to enable include selected frames into the mesh. Then you come to assign frame, then you edit the frame flow meshing options, and then you enable include selected frame objects in mesh. Then you okay. Then you can close. Then you can still sample to one slab, right click, see if the rods are there. So all rods on the slab still exist. Then okay. So next we shall need to check our model and see if it is ready to be analyzed. So we shall come to analysis, to analyze, then check model. Then you can select all, okay. Then we shall wait to see if there are any warnings or errors in our model. So since the model has been checked, no warnings were generated. So we can go ahead and analyze. So when you come to our analysis, analyze, run analysis has a shortcut of F5, and it also has a quick access icon here, which you can play. Then we are now able to run analysis, but before you run analysis, you should have saved your file in a desired location folder. So after running analysis, you can be able to close this view so we can look at our 3D view. So when we come to display, we can able to display our deformed shape, which has shortcut of F6 and which also has a quick access icon here. So the deformed shape will help us to show the deflections on our components. So we can come and use a combination. So we can use the limit state, then we can apply. Okay. So when we move around the components of our model, we can able to see, for example, joint label 8, which is at the storage 3, has a deflection of 2.354 in the Z direction. So Z is the vertical directions in Etabs, and this will give us the deflection at various points. So if you want to see the beam and column moment, shear force and bending moment diagrams, you'd come to the display tab. Then you'd look at display force or stress diagrams. Then you look at frame pier span rounding forces. So in this case, you can set the load case to combo, limit state, then enable moment at 3. Then you can be able to enable show values at controlling stations and diagram. Then we can look at the frames, apply. Okay. Then we can close. So when we come into our frame members, so here this works for the beams and columns. So when we select a column and right click, it will be able to display the maximum shear and moment on that component, which could help us to be able to design our elements. So the same goes for the beams. You can look at one of the beams, right click on the beam, then you enable show load combinations. So this gives us both the deflection and moment diagram and shear force diagram on that beam, which could help us in our design of that element. So next we can look at displaying for shell stresses. So still on it has an icon here, which is F9, but when you come back to the display tab, deformed stresses, you also get it here, displaying shell forces. So to display shell forces, one has to be in a plan view to be able to view the forces in the slab. So we shall come here. Add a new window. Apply, close. So coming to display our shell forces in our active window. So we have to use a combination, and for the showed it. And our component, we should enable FMAX, or FVM, according to the forces we need to get, or the maximum moment. Then when we look at compare contour appearance, we have to show fill and also values by enabling them. And show min or maximum as arrows. Then in the contour, still in the contour option, we have to enable display on deformed shape. Or you can show lines, so you apply. Okay. So from this, we could be able to see forces on our slab. So when you right click, so in order to see reactions at our base, we could come back down. So we are now at our base. So coming to our base, we can able to select the base in order to show the reactions or the forces at the bottom of our columns. So you can select the entire base. Then you come to display joint reactions. Then you choose a combo. You can enable prototype as tabulated. Then enable FZ, apply, and OK. So this gives us our base reactions at the end of the columns in our structure. So the next phase, we shall look at designing reinforced concrete structure, which will enable us to get steel values to be able to insert into our drawings.